All right, so I'm gonna skip count by 6. I'm just determining whether it repeats or not. I'm gonna skip count by 6. And of course, there will be no multiplication chart on the table, not on the test. You can't get any groups of 6 out of 5. Tanaya, whenever you get confused on that, you just draw 1, 2, 3, 4, 5. Can you get 6 out of that?
Excuse the interruption. If you're missing any baseball pants, come to the office. If you're missing any baseball pants, come to the office.
And how many groups? 8 times, which is 48. And then add a 0 and bring it down. How many groups of 6 can I get out of 20? 3, which is 18. 20 minus 18 is 2. What's going to happen?
It's going to repeat.
It's going to repeat the.
A line above it.
Okay. You don't even have to write it, but you could if you wrote it. You would put the line above the 3.
That's fine.
And then, but here you just put repeats for me, okay? Everybody got it? All right, let's take a look at 8/18. Can somebody close my door? It doesn't matter. We're going to take a look at 8/18, guys. And again, you won't have a multiplication chart, nor will you have a calculator for this portion. So you're going to make sure that you can skip count, guys. Okay? So let's do top end, bottom out, add a decimal and a what? All right. 18. What is 18 plus 18?
36.
Mm-hmm. Kayla, you with me? What is 36 plus 18?
72.
Mm-hmm.
90.
Very good.
100.
Very good. 126.
We went to 100.
Y'all got 144. We're good? We'll get off somewhere?
Only went to 108. I didn't even go that far.
Okay, well, it's fine. I don't need to keep going. All right. No groups of 18 out of 8. And that will take us to the number 4. 4 groups. Everybody with me? You got to know how to skip count, guys. You're going to get another 80, which is another 4. What's happening? This is going to repeat. Okay? Everybody got it? Y'all sure? How many people had this before me? Thank you. Some of you all can tell are waiting on me to do the what? Do the work, yeah. Some of y'all just waiting on me to do the work, and that's not going to help you when it's time to take the ACAP test. Okay? So next week is our last week of review. That's it. Or teaching or learning. I'm not worried about the negative. I'm worried about the 3/12. I'm going to do in and out. Add a decimal and a. I'm going to skip count by 12s. That's about as far as I'm going to go, guys, because that says 30, all right? Everybody with me? If I need to, I'll keep going in just a little bit. No groups of 12 out of 3. Any groups of 12 out of 30.
24.
2, which is 24. There's actually 2 groups, which is 24. That's 6. Yeah, I need to keep going. Because now I got a 60. So if I add 12, 12 times 5 is 60. That will be exactly what? 5. Now you get a remainder of 0. So is this terminating or repeating? Terminating. It stops. You get a remainder of 0. Okay. Are we good on that? We are? We can do this on the ACAP test by ourselves? Okay. Okay, one more, and that's 111. All right, I'm going to do in and out, okay? Then we're going to go into probability today. Add a decimal and a 0. Skip counting by 11 is easy. So forth, okay? All right, now I can't get any groups of 11 out of 1. Can I get any groups of 11 out of 10? No, so I'll write a 0 and subtract a 0. Add another 0, bring it down. I need to keep going over here. 99, okay, which is exactly 9. 100 minus 99 is 1. Start over. Can I get any groups of 11 out of 10? Okay, so what is it going to repeat? More than the 0, the 0 and the 9, okay? It's going to repeat the 0 and the 9. So this is also repeating. You only had one up here that was terminated. That is all you do. You got it right? All right, guys. I'm going to pass out a set of notes while you check your homework. I'm going to erase this. Let me erase this. And you're going to check your homework. I wish I just would have printed it. But I didn't. Because if I print an answer key, it's just going to roam around. Somebody will take it with them and give the answers to somebody else. Some of y'all already gave your answers to somebody else anyway. All right, so you're going to check your homework. So the first one you're going to check is number 1. Yeah, I did. I don't know what that is. I'm going to go check. All right, y'all going to check 1 and 2 while I go look at this. I need to see if this is over here, okay? Y'all check 1 and 2. Hey, I don't need to hear you. Everybody needs to be able to see. We're not going out of the classroom. No restrooms, no water. Wait till the bell rings. All right, any questions about 1 or 2? Any questions about 1 or 2? If so, I will explain. Nobody has a single question. How many of you did well on 1 and 2? Okay, good. Good. All right. So the constant of proportionality is 8 grams of protein per cup. What you could have done is found an X of 1. Here's an X of 1. 1 cup is how many grams of protein? 8. That's your unit rate. Or you could have chosen any ordered pair like this ordered pair. That is 2 cups of milk and 16 grams of protein. And you just take your Y and divide it by your X. So 16 grams divided by 2 cups of milk equals 8 grams per cup of what? Lord have mercy, per cup of grams, per cup of milk. Do y'all understand that? Y'all sure? How many of you found the X of 1 and just said 8 grams of protein for every 1 cup of milk? Okay, that's fine. How many of you just took a point and divided? Everybody take a point and divide? Okay, that's fine. You can pick any point and divide, okay? All right, B, what does 0 mean? If in 0 cups of milk, there are 0 grams of protein. But make sure you put cups of milk first, because on your x-axis is the cups of milk. You name that first, and then you talk about the grams of proteins, okay? Everybody with me? All right, C, what does this mean? In 4 cups of milk, there are 32 grams of protein. All right, 2, I need the constant of proportionality for A. So all I did was pick this point for A. And that is the ordered pair 2 and 6. So I took my Y and divided it by my X. So I said, well, that's 6 divided by 2, which is simply 3. So for line A is 3. All right, or you could have also looked at line A and found an X of what? An X of 1, and what does it go to? 3. Everybody see that? Or for line B, you could have chosen something like, I don't know, like this. That's the ordered pair 3, 3. So if you take Y and divide it by X, 3 divided by 3 is 1. Or you could have found an X of 1. There's an X of 1. And then it goes to a Y of 1. So I could tell that here the unit rate is 1. Here the unit rate was 3. Does that make sense? All right, let's take a look at this one. Now I know I had more than that up. Okay.
Go down.
No, that's not it, baby. I know what the problem is. The problem is it did not upload the second page.
It's up top.
It didn't upload the second page, baby. You're not listening to me. Is it up top? Is it backwards? Oh, thank you. Sorry. I'm so sorry. All right. I got to close my door, y'all, again. I'm sorry. Tonight, close it one more time, baby. I can't take it. Close the door one more time.
It's making my head hurt even worse.
It's moving smart boards or something. I don't know, but it's getting on my nerves. All right, look at 3. All right, Tiana uses the equation C equals to 21H to figure out the total amount C. C is the total amount C, which she could charge for a customer for babysitting for H hours. So C is basically what she's going to charge. So what is she charging per hour? So you can look at the equation and tell what she's charging per hour. What is she charging per hour according to the equation? She's charging $21 per hour. You can see it right there. That's her unit rate, okay? Makes sense. All right, Tiana charges this for a job. So how long did she babysit for? So all I did was write the equation down, and I changed C, which is the charge. I just changed C to $94.50. And then I ended up with a 1-step equation, and I solved it. So if you have a 1-step equation, you just get rid of what's on the side with the variable, which is 21. It's mashed together, so what do? It's mashed together, it is multiplication, so we divide both sides by 21, and it tells me that she worked for 4.5 hours. Does that make sense? Y'all sure? All right, on 4, the graph shows the proportional relationship between the number of minutes Oliver spends reading and the number of pages he reads. It says pick 2 points on the line and just tell me what they mean. So I picked 2, 3. 2 is the number of minutes, and 3 is the number of, in 2 minutes, Oliver can read 3 pages. That's all that means. All right, and then I picked this point where 8, was the number of minutes, and 8 went to 12. 12 again is the number of pages. So in 8 minutes, he can read 12 pages. How many people, did anybody have a problem reading the points? No?
The number 4 was, and number 5 was really confusing.
That's super easy. All right, 5, the point 5.2 means Savannah's dog eats 5 pounds of food. Well, 5 is your X. So if I look on the X, 5 doesn't represent pounds of food. It represents what? Days. So that's automatically false. Okay? This just means in 5 days, they eat 2 pounds of food. All right, the constant of proportionality is 0.4. So what I did is I found an X of 1, which is right here. And what does it go to? 0.4. So that's the constant of proportionality. I also took a point and I divided it. Like I found this point. That's the point 5.2. This is the point 5.2. So I took my Y, which is 2, and divided it by my X, and I also got 0.4, just to double check it, okay? All right, Savannah's dog eats 4 pounds of dog food in 10 days. So heads up, guys. I went to this one because in 5 days, that dog can eat how many pounds? In 5 days, the dog can eat how many pounds? How many? 2. So that means if they eat in 5 days, he can eat 2 pounds. But in 10 days, they eat another 2, or 2 plus 2, which is 4 pounds. So is that true? Yes. Or what you could do is use the equation y equals to 0.4x, because that's my unit what? And then you could just change x to 10 and multiply them and get 4. All right, D, the equation represents this relationship. No, this is the actual equation. 2 is not my unit rate, 0.4 is. All right, no questions? All right, let me pass out your notes for today. Okay, to me this stuff is easy. I hope this stuff is easy for you all. 2. 1, 2. All right, 1. And 1, 2, 3, and 4. There you go. All right, so we're going to go into probability today. And the first page is for you all is page 675. So let me get there. All right, so we're going to look at this page. How many people are familiar with a die? A die. How many sides are there to a die? How many sides are there to a die? 6. Okay. I'm going to give everybody 1 so y'all can have something to take. Okay. Everybody gets a die. Please don't roll them or throw them or hit people in the head with them. Okay. All right, so let's take a look at this. I'm just going through the already pages. It's real quick to me. For me, it's going to be real quick. All right, a standard number cube, which is a die. A standard number cube is nothing but a die, has how many sides? 6. And they are labeled 1 through 6. And you can look at yours. 1, 2, 3, 4, 5, and 6. Okay, 6 sides. The numbers 1 through 6. All right, so it says, think about rolling your number cube, but think about rolling it. We're going to look at A. is it more likely that the cube will show a multiple of 2 or a multiple of 3? Okay, who can tell me what the multiples of 2 are? What are multiples of 2? On the die, look on the die. What are the multiples of 2? Is 1 a multiple of 2? In other words, can you skip count by 2? Skip count by 2 for me. Okay, so a multiple of 2 would be 2, 4, and why don't I worry about 8? It's not on the die. Okay. All right. Who can name the multiples of 3 that are on the die? Raise your hand. Okay. The multiples of 3 that are on the die are 3 and okay.
You can't do 9 because it's not on the die.
Yeah, you can't do 9. It's not on the die. So I'm gonna ask you a question. Do you think it's more likely that you'll roll one of these, a multiple of 2, or a multiple of 3? Why? There's more of them than the multiple of 3. So I want everybody to circle a multiple of 2 is more likely. There are more of them. This to me is common sense. It should be. Okay, everybody with me? All right, it says, how likely is the cube to show a 3?
Not very much.
Why not?
Because there's less multiple of 3s.
No. It doesn't say to show a multiple of 3. Does it say how likely is the cube to show a multiple of 3? Or how likely is it to show the 3? A 3. How many 3s are on the die?
1.
How likely is it for it to roll on a 3? Is it very likely? It's not very likely at all. Why not? How many are there on here? There's on how many 3s are on this die? 1. Okay? It's only 1 3 on here. Everybody understand? Are y'all sure? This is not likely. I thought this was gonna be easy. At all, okay? Why? Why is it not likely? There's only 1 3 on the die. Have y'all never done probability at all? A 1 is not likely. A 2. What they say is, when I ask you how likely is it to roll a, if I could ask you to compare it to the other one, you say it's equally likely. If I say compare it, it will be equally likely, but it's still not very, okay, that you might, it's equally likely as the others though. All right, let's take a look at C. Why is it just as likely that the cube will show an even number as an odd number? Why is it just as likely? How likely is it to roll an even number? How many even numbers on the die? Name the even numbers on the die. 2, 4, and 6. Okay, who can name the odd numbers on the die?
1, 3, 5.
Okay, so why do we say that it's just as likely that you are rolling an even number as it is that you are rolling an odd number? Why do we say it's just as likely? Because both of them have the same amount of even odd numbers. That's why we say just as likely means equally as likely, okay? So another word for just as likely, you'll see, is equally as likely. But the reason why, here's the why. There is the same amount.
Announcements from the office. If you're in the hall, you need to go to your class. If you're in the hall, you need to go to class. Thank you.
there is the same amount of even and odd numbers, guys. Okay, they're the same, so they are equally as likely to happen, okay? There are 3 even and there are 3 odd. Everybody get it? Three even, 3 odd. The same amount. So it's equally as likely to land on an even number as it is to land on an odd number. Is this making sense? Okay. All right, look at 2. Doing something where you cannot know the outcome is called an experiment. Okay. So if I ask you to toss the die or to roll it, that's an experiment because you don't know what it's going to. Okay. So if you're rolling it, it's an experiment, guys. You don't know what's going to happen. The outcome is what's going to happen in the very end. Okay. All right. And problem number 1, rolling the number cube is if you roll it, it's an experiment. The outcomes, underline this, the outcomes are the possible results. What are the outcomes of rolling the die here? What are the possible results or outcomes of rolling the die? What could happen? It could land on a, give me the numbers it could land on. It could land on a 1, 2. So on A, when it says, what are the possible outcomes of rolling the die? Well, you could land on it could land on a 1. It could roll on what? 1. What else could it roll on? 2.
3, 4, 5, 6.
Those are the only outcomes of rolling a die, a regular die. That's it. Okay? Y'all get it? Ooh, I thought this was going to be easy. All right, an event is a set of 1 or more outcomes. So, as an example, they have something for you, a question. What are the possible outcomes, and here's the event, for this event? What's the event? Rolling a multiple of what?
2.
What are the possible outcomes for rolling a multiple of 2? In other words, how could you get a multiple of 2? It could land on what? It could land on 2, 4, and these are the possible outcomes of this event. That's the event, guys. Possible outcomes of that event. The event is the thing that happens. If you want to go to a concert, that is the event. That's the thing that you did. What is the thing that I want? A multiple of 2. That is the event. Okay? Everybody with me? What is the possible outcomes for rolling? Huh? I didn't even finish. Okay, never mind. What are the possible outcomes for the event of rolling a multiple of 3? 3 and 6. That's all you're going to do, guys. Okay, this is just an introduction. Are we good? What are the possible outcomes for the event of rolling an even number? An even number. 2, 4, and 6. Okay, that's for the even number. What are the possible events for rolling an odd number?
1, 3, 5.
Okay, how many people clearly understand this? Okay. All right, let's flip over. All right, probability, underline this. Probability describes how likely an event is to occur. Is it likely? Is it not likely? Is it equally likely? Is it impossible? Okay, everybody with me? One way to describe probability is to use words. Next week, instead of using words, we're going to use numbers to describe probabilities, okay? All right, certain, underline this, guys. certain describes an event that will definitely occur. If it's certain, it's gonna happen. Okay? I was certain that the school was gonna open today. Cause every other school is open, but Coosa County said, we're going to school, okay? I don't know. All right, now, impossible. Impossible describes an event that could never happen. It just ain't happening. Everybody with me? You can never roll a 10 on a die. Why not on a regular die? There's no 10. All right, and then lastly, likely describes events that will probably, but not certainly occur, okay? It's probably going to happen, but I'm not certain about it. All right, events that will probably not occur, but can be described as unlikely because they probably won't happen. If it probably won't happen, it's unlikely. And if an event is likely to occur as not likely, it can be described as equally likely. So if an event is as likely to occur as it is not to occur, in other words, the outcomes are the same, we say it's equally likely, okay? Outcomes must be the same. In order for it to be equally likely, guys. Does that make sense? All right. Rolling a 7. What do we know about rolling a 7? It's what? Because how many outcomes are there?
There's only 1 through 6 and no 7.
So there is no 7s, okay? There are no 7s. What about rolling a number less than 2? How many numbers are less than 2?
1.
1 out of the 6. So this is very unlikely that I'm gonna roll a number less than 2. Because there's only 1 of them. So we understand why that's unlikely. It's not that many of them. Put that down. All right, what about rolling a prime number? Y'all know what prime numbers are? Okay. Prime numbers are numbers that are greater than 1. Escucha. Listen to me. Prime numbers are numbers that are greater than 1, but only have 2 factors. Like the only way to get them are 1 times something. Okay, so I'm looking at the numbers on the die. 1, 2, 3, 4, 5, and
6.
it's got to be greater than 1, so 1 cannot be prime because it's got to be greater than 1. What is the only way to get a 2 if you were to multiply it? What are the only 2 numbers you can multiply together to get a 2? So this one only has 2 factors. So therefore it is prime. Okay, how can I get a 3 if I multiply? 1 times 3 is the only way to get a 3. So this one is also prime. Okay, wait a minute. I'm not finished, love. What kind of way can I get a 4 if I multiply? 4 or this number is not prime because you can get it more than just 1 times 4. This is what we call a composite number. Have y'all never heard of these? Somebody did y'all so wrong. All right, how can I get a 5? 1 times 5, okay? Is there another way to get a 5? Okay, 1 times 5. So this number is also, okay, what about 6?
1 times 6, 2 times 3, and 3 times 2.
What's the same thing? But it's more than just 1 times 6. So this one is not prime. Okay? So what are my only prime outcomes? 2, 3, and 5. Rolling a prime number is equally as likely as not rolling a prime number. Why? How many prime numbers were there? How many are not prime? How many are not prime?
4 and 6.
1, 4, and 6. Okay. 2 is prime. 3 is prime. 5 is prime. But 1 is not. That's why it's got a big X over it. 4 is not, and neither is 6. So 3 are prime and 3 are not prime. So we say that it is equally likely as not. In other words, it's equally likely to land on a prime as it is not to land on a prime. All right, what about rolling a number greater than 1? Who can list the numbers greater than 1?
1, 3, 4, 5, 2,
3, 4, 5, and
6.
so this is very likely. Why?
Because there's more than
It's almost all of the numbers on the cube, right? Besides the what? It's almost certain, but very, it's not certain, but very likely. All right, what y'all know what an integer is? An integer is just a positive or negative number, but not fractions and decimals. All right, how likely is it to roll an integer? Like a number, a positive number or a negative number?
You can roll a positive, but you can't roll a negative.
No, it says or, either or. So what are the numbers on there?
1, 2, 3.
All 6 of these are called, all of these are integers. So how likely is it to roll an integer? It's certain, because every number on there is a what? Is an integer. Is an integer. Every one of these is an integer. It's just a regular number. But it could be positive or negative. But because all of them are positive, it works. They're still integers. 1's an integer, 2's an integer, 3's an integer, 4, 5, and 6 are integers. So it's certain you're gonna roll an integer, guys. Let's take a look at this one. 4 cards are in a bag. Each card has a picture of a lion, a giraffe, a goat, and a leopard. 1 card is selected from the bag at random. All right, who can name an event with the given probability? Who can name something that's impossible for me to pick? Is it impossible for me to pick a leopard? Couldn't I stick my hand and pull out that in the bag and pull out that card? What would it be impossible for me to pick? Something that's not up here, y'all.
A dog.
A dog. Okay, a snake. It's impossible for me to go in that bag and pick something that's not up there. Write down something that's not up there. A bird would have worked. I don't care. All right. It's certain. I'm going to go ahead and tell you. It's certain that I'm going to pick a picture of an animal. If I put, what's the probability you're going to get a picture of an animal? That would definitely be certain, because everything up here is a what? Is an animal. Okay, equally likely as not. Y'all know what leopards and lions are? They're considered big cats. Okay? They're considered big cats, okay? So it's equally likely as not that I'm going to pick a big cat. How many big cats are there? How many big cats are there? How many big cats are not? How many are not big cats? 2 are, and 2 are not. So they are equally likely. What is it unlikely that I'm gonna pick? I gotta be quick. Just pick one of them. It doesn't matter. A goat, okay? A giraffe. It doesn't matter. All right, how many of you at least understand those pages? Okay, y'all do? All right, we'll finish the rest on Monday, okay?
Say tomorrow.
Let me see how far we got.
We got to
Okay. All right, we'll finish. We'll do that tomorrow. On Monday. Hey.
You know, y'all gonna have that this weekend for homework.
Y'all have a good one.
How cheerleading go yesterday? That's great. Hey, Miss Blue, how you doing?
I'm fine. How are you doing? I'm a bit, I don't know. Ashwagandha is not working for me.
You be a what?
I'm a bit frustrated.
Oh no, it don't work over like a month. It's got to get in your system.
I've been taking that for probably like a month and a half.
Yeah, it's got to get in your system.
I've been taking it for a month and a half.
It's got to get in your
How
system.
long did it take to get in there?
can't go and say exactly when I started feeling mellow.
I don't feel mellow. You feel mellow because you got a building that allows you to feel mellow.
Oh, yeah.
That's why you feel mellow.
Yeah, I do go back the other way when I come back over.
I know you do, okay?
What's the little lady name? Little short lady be over here, Miss First Week Wrong. Miss Henley. Miss. Oh, she work at the extension. She came last year.
I talk to her all the time.
She came, she used to be over here, I mean, with Coach Lisa, she came about once a month.
All the light skin lady.
Oh, dark skin. About this tall.
I did not talk.
Miss Blue. She was, when I was in that field, she came at least once a month. Gave the kids the boxes, the little Delta boxes. What's the lady name that worked before 4-H? She's over 4-H. Oh, yeah, none of these kids are 4-H.
It's not what it be.
A little black lady, about this tall. Susan Henson.
I have no idea what you're talking
Oh,
Y'all work on 35. Take your homework out.
I'm wrong.
I promise I have no idea what you're talking about.
You know that.
I don't know.
Hey. So every time I shut up. Oh, you need to shut up today? Yeah. I'm really like that. I'm really too.
We got it.
Oh yeah, Dallas. Dallas. Well, you can get that to the white I got double T. Okay, put it up there.
What's up, Zay?
Pull your pants up.
That way. No, I'm going for two white.
Yes, I was so. It was so. Then he told me I almost went insane. February 1st, 2008. I You guys never start over. This was all right. I did the one. Wait, can you for a class meeting before she but yeah, this Alicia, what is it? What did you get from the first one? What is a constant?
What's like on a graph? What's the 0, 0?
Origin. Oh, yeah, homework. Yes. Number one. What's the constant? With the zeros. 8. 8.
Alright, now sit at the desk. I got plenty of desk, sit at the desk, I'm sitting at my table. Alright, let me check homework.
This everybody come here?
I'm just tired. I don't want y'all talking, okay? You know what? Kathy. You cannot use calculators on this phone. Zane, you're not doing bell work. That's for my 8th grade. Zane, you're supposed to be doing bell work, love. It sounds like it's no sub over here. And it sounds like there's a sub there, but no sub there. Tristan, I'm looking dead at you.
Oh, I'm blind, so may I get some earbuds? You're so cool.
Stop running.